Okay, so some things about notation that are important. I see that the book says, the particular book I was looking at, wanted me to point this out, and this is good. Cosine t divided by t does not equal, this is function notation. The t is inside here. I think everybody probably knew this. You'd be amazed at some things that don't get through, though. So I just wanted to make sure everybody was aware of that. So what did we figure out about sine and cosine in particular yesterday? And that is they're periodic. And the reason is they're periodic is because, and I'll draw this on the unit circle here. Remembering again, the unit circle just means that the radius is 1. It's just easy to compute with. Here's our triangle. This is alpha. Sine and cosine are periodic with period 2 pi. That means that cosine of alpha is exactly equal to cosine of alpha plus or minus 2 pi. It's actually cosine of alpha is equal to cosine of alpha plus or minus 2k pi. Now you're starting to go crazy. Where'd the k come from? Where k is some integer. And so if k is 0, it's just cosine alpha. If k is any integer, basically we're talking about wrapping around this unit circle. So here's cosine alpha. We're making the computation from here. So what if you add 2 pi? You get the same thing. 4 pi, same thing. 6 pi, same thing. Remember, this way is adding, this way is subtracting. Hopefully you can see that sine and cosine are periodic functions. And they behave very well, and they have a lot of great properties that we can use. So I'm going to remind you of some things that you absolutely need to know. And these need to be in your memory. I'll try green. It must be the case that, actually that's probably a little too light. It must be the case that you need to know that the cosine of 0 is 1. The cosine of pi over 6, which is 30 degrees, is the square root of 3 over 2. The cosine of pi over 4, which is 45 degrees, is 1 over the square root of 2, and some old people write it like this, the square root of 2 over 2. The reason is, back in the day before calculators, you used to have to use slide rules to figure out what stuff was in complicated formulas, and it was much easier to divide by a whole number. So the cosine of pi over 3, which is 60 degrees, is 1/2, and the cosine of pi over 2, which is 90 degrees, is 0. These you really got to know in an absolute way. Similarly, for sine, sine of 0 is 0. The sine of pi over 6, which is 30 degrees, is 1/2. The sine of pi over 4, which is 45 degrees, is 1 over the square root of 2, which is, I'm just fine with this. And you're probably going, you're repeating yourself about 1,000,000 times, calling out the radians and degrees. And the truth is I am, on purpose, because I want it to sink in your brain. It's just like those annoying commercials. Remember the one with the cats? Meow, 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 meow. Who didn't almost get sick with that in their head for like 50 years? But anyway, the sine, that was just silly, I know. The sine of pi over 3 is the square root of 3 over 2, and the sine of pi over 2 is 1. The reason why these are so important is because these, number one, they show up quite a bit, but number two, these are all defined in the first quadrant, and once you know these, you can figure out what anything else is. And I'm going to show you how. Okay, so we'll make this a unit circle. I'll make this a big unit circle. And okay, so let's look at an easy one. Here is 45 degrees, which is pi over 4. We already know that sine of 45 degrees, which is pi over 4, equals the cosine of pi over 4, and that equals 1 over the square root of 2. So this point right here, remember that sine of alpha is y divided by r. If this is equal to 1 over the square root of 2, you can think of this in two ways. This is y, and this is r. However, and that would be perfectly fine, 1, 1, square root of 2. But remember, I called this out as the unit circle. And that means that this entire thing is y, and we're dividing it by 1. And that probably was just a little confusing. However, it's important because here's this point on the grid, 1 over the square root of 2, 1 over the square root of 2. When you're on the unit circle, sine and cosine just appear as these points, whatever their values are around the circle. And this is one of the things that makes it valuable and useful. Anyway, so now I need to think about this. Suppose I want to figure out what this is. First off, what I did is I'm climbing pi over 4 degrees back from here. This is 3 pi over 4, which is 135 degrees. 45 is 90, plus 45 is 135. If you wanted to figure out what this was, this is simply pi minus pi over 4, because I'm at pi here, I'm going back this way. Pi is 4 over 4 pi, minus pi over 4 is 3/4 pi. So let me look at this. So the real question is what are the trigonometric functions at this place? How do you know that? And I'm going to put the 3/4 pi here. And actually, let me show you something too, which you'll also might seem a little odd. Remember, the degrees we're counting, the way that we're counting is over this way. Where the red is here, this is actually the 3/4 pi. I'm floating it in this little corner here to keep it out of the way, but the truth is the triangle that we're going to use to figure out these things is based on this picture, right? So anyway, we already know that this point, the length here, x-wise, is 1 over the square root of 2. The length here, or the height here, I suppose, is 1 over the square root of 2. So what is this? Well, this is just a mirror image, except on this side, this is minus 1 over the square root of 2, and this is positive 1 over the square root of 2. So we write this up. This is minus 1 over the square root of 2, and 1 over the square root of 2. Similarly, what if we wanted to go down here? So what is this? We're at pi right here. I'm adding 45 degrees, or I'm adding 1/4 pi. This is 5/4 pi. And let me be clear about where that is. 5/4 pi is all the way around here. But here's the trick. We're using this triangle right here to make our computations. Okay. And I remember, I'm trying to be very careful with this, because I remember when I was first learning that confused me quite a bit. But, so this one. Now, in this case, we already know what's going to happen. We know that x is negative 1 over the square root of 2. In this case, y is going to be mirrored down. This is negative 1 over the square root of 2. So this point on the unit circle is negative 1 square root of 2, negative 1 square root of 2. And that's about it for our 9 minutes. We'll be back right after this advertisement.